Hi, hello, welcome to Master Pharma. Today our topic is isomerism. So in this isomerism, we have different types of classifications, right? So we are discussing about isomerism. Yeah, this is the very familiar word, very known word from intermediate standard, okay? Isomerism. Iso, we know. Iso means same. Merism or mer means molecular formula. So same molecular formula. Then what is difference? If it is same molecule, there is a difference. The difference is arrangement. The difference is arrangement. Different arrangement, same molecular formula, different arrangement. For example, same set, so one person arranges one compound in a different way, that is called different arrangement. So that is isomerism. Generally, molecules, so group of atoms is called molecule. So molecules having the same molecular formula means, for example, C3H7O. Next compound also having C3H7O. This is called molecular formula. So both compounds, for example, compound number X, compound number 1 and compound number 2, otherwise compound X and compound Y, having the same molecular formula means number of carbons, number of hydrogens, number of oxygen, or whatever the number. So number of any atom is equal, but the arrangement is different. That is called isomerism, right? See, yeah, how can we define? It is very clearly molecule first. Molecule, okay, divide into two types based on the type of atoms or arrangement of atoms, right? So molecule here homomer, here isomer. Isomer. So both are having same molecular formula. Both are having same molecular formula. Here, non-superimposable. Non-superimposable. So non-superimposable means these two, right? So one is not 100% matches with another one. This is called non-superimposability, right? Right hand, keep the left hand and right hand. So it is not matches. This is called non-superimposability. If it is superimposable, that is called homomer. Homomer means same, identical compound. Both are same compounds, right? That is called superimposability. Right? So here isomer. Isomer having same molecular formula, different arrangement. So that arrangement is two types. The two types is, first one is constitutional arrangement. Constitutional means, so like carbon-carbon bond, right? So straight chain, round compounds, or whatever the compounds, constitutional. Here stereo. Stereo means in spatial arrangement. Constitutional isomerism and stereo isomerism. Again, this constitutional isomerism is divided into almost 6 types, but majorly it is divided into 5 types only. So specific type also included, that is 6 types. Generally it is 5 types. Constitutional isomerism, so that is attached each and other in different manner, right? So this constitutional isomerism again divided into 6 types. When to learn 6 types, so that is also converted to 5 types also. Yeah. So first one is constitutional isomerism. Constitutional. Another name, structural isomerism. Structural isomerism. So in the structural or constitutional isomerism, we have different structure. Same molecular formula, different structure, right? So first one in this. First one is positional isomerism. Positional. So based on the name, positional means position. For example, if you take this compound, can anyone, what is the name of this compound? Here give the numbering 1, 2, 3, 2-chloropropane. 2-chloropropane. Then coming to this compound, CH3, CH2, here CH2, Cl. Give the numbering 1, 2, here 3, 1-chloropropane. Did you observe the difference between these two? Both are chloropropanes, but the position is 1, right? That is called positional isomerism. Here also chlorine, here also chlorine, but the position is different. So number of carbons, number of hydrogens, number of chlorine atoms also same, but the arrangement, position is different. Those are called positional isomer. For example, propanol, isopropyl alcohol, these also belongs to this category. CH3, here CH, OH, again CH3. Another compound is CH3, CH2, CH2, here OH, 1, 2, 3, here also 1, 2, 3. 2-hydroxypropane, 1-hydroxypropane, otherwise isopropyl alcohol, right? 1-hydroxypropane, otherwise propanol, 1-propanol and 2-propanol. So these two types are belongs to the positional isomerism, right? Coming to the next one, next classification, that is tautomerism. Second one is tautomerism. So there is a word tautomerism, what we remember, there is a keto-enol tautomerism. Keto-enol. One is keto form, another one is enol form, tautomerism, right? This is one type of isomerism, molecules having same molecular formula, but convert the one structure to another structure, keto to enol. We know this is the structure of keto, C double bond O, bonds are called keto. Enol means, en means there is a double bond, all means there is a alcohol. En means double bond and ol means alcohol. For example, if you take an example, here CH3, here C double bond O, here CH3. Give the numbering 1, 2, 3, 2-propanone, right? Otherwise, this is called, trivial name is called acetone. Acetone. So this is ketone because C double bond O is present in this one. So this ketone is converted to enol. What is the meaning of enol here? Double bond and OH molecule. How it is converted? See. Again I am going to write the structure. CH2, here H, C double bond O, here CH3. Okay, CH3, C double bond O, CH3. I am going to write the structure like this. So this is, we know this is carbonyl compound. Electrons are moves towards more electronegative oxygen side automatically. So here partial negative, here partial positive charge, right? So this is hydrogen is attracted by here and this bond is moves over here. What will happen? CH2 double bond C, here OH, here CH3. This is double bond. En, here hydroxyl group, enol, right? This is called propanone. Okay, otherwise acetone. So acetone is converted to, give the numbering 1, 2, 3, 2-hydroxy, yes, 2-hydroxy, 1-propene, not propane. Here first position there is a double bond. So this is called keto-enol tautomerism. See, observe here, CH3, C double bond O, CH3, here CH2, C, OH, CH3, there is a double bond. So number of carbons, number of hydrogens, number of oxygens, all are same, right? This is belongs to the ketoenol tautomerism, right? Next, coming to the third one, third classification. So what is third classification here? Metamerism. This is somewhat different but very easy. Metamerism. So many of the students are confused about there is a meta position in benzene ring. There is no relation between those meta and here the metamerism. So metamerism, blindly you just remember metamerism occurs in esters only. There is a metamerism, you just simply remember here esters. Okay, ester. What is the formula of ester? R C double bond O, here O and R. This is called ester. For example, if you take one example, R is replaced by methyl, C double bond O here, O again R is divided into classified as ethyl. Okay, how can we give the numbering for esters? So after hydrogen, after oxygen, we should write this is prefix and this is suffix. Okay, yeah, this part is called prefix and this top part is called suffix. So what is the prefix here? Ethyl. What about suffix? How many carbon atoms? 2. So acetate. This is the compound, ethyl acetate. Then what is the isomer of ethyl acetate? The particular isomer belongs to the metamerism. For example, I am going to write the structure like this: CH3, here CH2, here C double bond O. Yes. Next O, here CH3. Just simply, I just shuffle this molecule to this area and this one is moves towards one and another. One is replaced by another. So CH2, CH3, here CH2, CH3. Next C double bond O, C double bond O, O, here CH3, here CH. Just to reverse the structure. Just reverse the structure. This is belongs to the metamerism. Simply, blindly, you just remember there is a metamerism involved in the esters only. Okay? Ethyl acetate. Here methyl propanoate because 3 carbon atoms here. 3 carbon atoms involved in this suffix area. Okay? This is called metamerism. Next, coming to the next classification. Functional group isomerism. Functional group. Functional group isomer. We know number of functional groups. For example, aldehyde, RCHO is called aldehyde. Next, RC double bond O, R is called ketone. Next, ROH is called alcohol. Next, RNH2 is called amine. Okay, so these are the functional groups. Functional group isomerism means molecules having the same molecular formula but different functional group based on the name. Different functional group, that is called functional group isomerism. For example, I am going to write the structure here. See, observe carefully here. C double bond O, here CH3. Next, second structure CH3, here CH2, here C double bond O, here H. So first structure belongs to the ketone category, second structure belongs to the aldehyde category. Here one is ketone, another one is aldehyde, but both are carbonyl compound family, carbonyl chemistry family, right? Number of carbon atoms 1, 2, here 3, 1, 2, 3. Number of hydrogens 3 plus 3, 6. Here 3 plus 2 plus 1, total 6. Number of oxygens both same, 1 and 1. So this is functional group isomerism. Functional group isomerism. Different functional group only. Different functional group. Next. Yeah. Next classification. Next. Ring. Ring. Isomerism. Ring isomerism. This is very rare, but it may be present, right? So ring isomerism. See carefully here. This is cyclohexane. This is cyclopentane. And this is cyclobutane. This is cyclopropane. We know C6, H12 here. Here C5, H10 here, here C8, sorry, yeah, C4, H8, C3, H6. Okay, so these are the structures and molecular formula, right? So what is the relation between these two? Here C6H12 means there is a loss of one hydrogen and one carbon and two hydrogen atoms. For example, I am going to write the structure like this: CH3, right? Next here CH3, next here CH3. So here CH3, now the structure is converted to C6H12. So now it is converted to C5H10. This is also converted to C4H8. Check it once. Okay, right. So the relation between these two rings is called ring isomerism. And these two rings are called ring isomerism. And these two rings are called ring isomerism. Ring isomerism. For example, compare these two. For example, here another methyl group. So what will happen? C5H10. So now C5H10 and C5H10 are belongs to the ring isomerism category, but this is very rare. Okay, just simply remind this. Next, last one is chain isomerism. Chain isomerism. So based on the name, different chain. For example, a molecule having the same molecular formula, but different length of chain is different. For example, see here CH3, here CH2, here CH2, here CH3. This is called N-butane. Next CH3, here CH, here CH3, and here CH3. 1, 2, 3. 2-methyl propane, here N-butane. Both are having same number of carbons and number of hydrogens, but chain is different. Chain length is different. Okay, so these are almost similar to the. These are what is that? There is a positional isomerism related to the positional isomerism. So positional isomerism example is, for example, CH3, here CHCl, here also CH3, next CH3, here CH2, here CH2, here Cl. Okay, so here also first position, here second position, almost similar to. So there is a confusion between chain isomerism and positional isomerism. So in chain isomerism, exclusively carbons are involved. Exclusively we should concentrate on the carbon chain. In positional isomerism, the substituent is more important. Substituent play an important role. Here the substituent also carbon containing compound. Okay, here there is no substituent as no carbon containing as a substituent. So this is called isomerism. Okay, yeah. Yeah, once again see. Isomerism, first one, positional tautomerism, positional tautomerism, metamerism, functional group isomerism, ring, here chain, ring and chain. So these are the 6 types classifications. We already discussed about the examples of each and every one, right? So you can read out number of examples, we can easily find out, right? Thank you all of you. Thank you for watching.